All right, this is the second portion of your study guide. You had to finish this last page for the second installment. So let's gonna go ahead and go through it. In number 7, 8, 9, you had to understand context. You had to kind of be able to work with rational numbers. Sometimes they were mixed numbers, sometimes they were whole numbers or decimals, but you had to be able to work with them well. So the first one, Sandy has a whole bunch of fabric, and she needs 2 1/5 yards to make one costume. How many costumes can she make? Well, we're doing division. We're dividing what she has by what she needs to make one costume. First thing I did was I just made them both fractions. I turned 9 3/7 into 66/7 by multiplying 7 and 9 and then adding 3, and that turns into this. Do the same thing with 2 1/5. Turn that into 11/5. Now, once they're both fractions, I'm doing division. So I just rewrote this problem with them both being fractions, and now I know my steps for fraction division are keep, change, flip. So I did that. I kept the first fraction the same, I changed it to multiply, and I found the reciprocal of the second fraction. 11/5 becomes 5/11. Now, I cross-canceled because I know that 11 goes into both 66 and 11. So I looked at those diagonals and I simplified them now because otherwise I'd be getting some pretty big numbers that might be tough to simplify later. I couldn't do anything with the 7 and 5, so I kept those the same. And when I multiply across now, 6 times 5 is 30, and 7 times 1 is 7. So I end up with 30 over 7, which I changed back to a mixed number of 4 and 2/7. But you can't really have 2/7 of a costume, so we went around this one down. 4 costumes is what we can make. All right. In number 8, Silver Dollar City tickets cost $23 for adults and a little bit, a little bit less than that for kids. So how much would it cost for a family of 5 to go? And it tells you that they have 3 kids. The first thing I did was I just kind of set up a number sentence. We have 2 adults, $23 each. We have 3 kids, $12.50 each. So this is what we want to solve: the adult cost plus the kid cost. And then you just work it through and you get $46 plus $37.50 is a grand total of over $80, $83.50. Number 9, Amari is saving to buy new wireless headphones that cost a lot of money. Each week he saves $18.50. How many weeks will it take to save the money? Now you could do this a few different ways. You could add up $18.50 over and over and over again until you finally get there. You could do division. You could do some multiplication to kind of speed up the addition process if you did that. But you really want to do, like I just did division here. So I know I can't divide by a decimal number, so I slide that over and I kind of turned it into that. Now I just moved it back one space because that 0 isn't really needed. So if I move this back one space, I want to move it back one space over here and turn that into 2380. So then I do division, 185 into that number in the 2000s. And I kind of worked through my steps and I get 12 point something. Now, I know it's going to keep going. I did not finish the work though because I realize that it's going to be 12 point something. So it's more than 12, but less than 13. So really, I kind of think about this, and the answer is that it's going to be a little bit more than 12 weeks, but 12 weeks isn't enough because it's more than that. So I just want to round this one up to 13 weeks. If I say 13 weeks, then he'll definitely get there, okay? So that would be this particular answer. Now, the rest of these down here, you had to do some math. These were just straight problems. There was no context. It was just work these out. So if I kind of start clicking through number 10, you're adding a positive with a negative. First thing I did since they were fractions is I made them have similar denominators. I put them both over 24. And then from there, you can kind of work it through and you can see that we're adding 2 numbers that have different signs, a positive number and a negative number. So subtract 20 and 15, you get 5. So my answer is 5/24, but since the 20 was bigger than 15, I take the sign of that one. That's why it's negative 5/24. Number 11, I made them have similar denominators first. This is one way to do it. But I also know I'm subtracting a negative number here. So when I'm subtracting, I want to keep change. So I kept the first one, 2 and 8/18, negative 2 and 8/18. Change this to addition and change this to positive 4 and 15/18. And I can do a few things once I get to that point, but I end up with 2 and 7/18. So that's number 11. Number 12 was a decimal problem. This is another keep change one because we are subtracting irrational numbers here. So negative 12 stays the same. Change your subtraction to addition and change the 10.26 to its opposite one, to negative 10.26. And now I've got two signs that have the same symbol up front. They're both negative. So I just really add those numbers and keep the negative sign. Number 13, I have two mixed numbers. So my first step was to make them both fractions. Then I could cross cancel the 24 and the 2 by dividing them both by 2. This becomes a 1. That becomes a 12. And then I multiply across. I get 108 over 7. I know my 7 times 15 fact. That's 105. So 7 goes into it 15 times with a little bit of a remainder. 3 is my remainder and it stays over 7. So 15 and 3/7. And the last problem here, you have a mixed number divided by another mixed number. So I change them to fractions, both of them. And then I keep change flip. Keep your first fraction, change to multiplication, and then flip the second one. You can cross cancel if you want, or you can just multiply across. But I do know when I'm multiplying both of these, they have negative numbers out in front of both. So my answer will be positive because a negative times a negative is a positive. And I can simplify that to 4/7. That brings this part to a close. You've been a great audience. Have a great day.